Hello class, in this video I'll be showing you how to find all of the zeros of a polynomial function and how to rewrite a polynomial function in completely factored form. Let's begin. We will start with the fundamental theorem of algebra, and it states every polynomial function of degree n is greater than or equal to 1 has at least one complex zero. And by complex, I mean a complex number. Complex numbers are of the form a plus bi or a minus bi, where a and b are real numbers, and I is equal to the square root of -1. So now let's take a look at an example. Find all zeros of m of x and rewrite m of x in completely factored form. To do this, we're going to start by looking at the degree of m of x, because we want to know how many zeros m of x actually has. So the degree of m of x is 5. So by the fundamental theorem of algebra, m of x has 5 complex zeros. And here it's good to note that all real numbers are complex. And that is because if a is a real number, then a is equal to a plus 0i, or a is equal to a minus 0i. Okay, so now let's find the zeros of m of x. And I'll start by finding the rational zeros. To do that, I'm just going to graph m of x in Desmus. So here we have m of x entered into Desmus, and to the right, there's the graph. You may notice that m of x has 3 horizontal intercepts, or 3 zeros. One of the zeros is -3, and that is rational. The other 2 zeros look like they are irrational numbers. So what I'm going to do is I'm going to use -3 to find the other 4 zeros. So from Desmus, we have x is equal to -3 is a 0 of m of x. And I'm going to use synthetic division to find the other zeros. So I'm going to set up the synthetic division, and we have 4, 12, 0, 0, -1, and -3. Bring down the 4. -3 times 4 is -12. 12 minus 12 is 0. And I'm going to finish synthetic dividing. And just like expected, since -3 is a 0 of m of x, the remainder is 0. So now we have the 4 and the -1. 4 is the coefficient of x to the 4th, and -1 is the constant term. So 4x to the 4th minus 1 is a factor of m of x. And now we're going to set that factor equal to 0 and solve for x. So we have 4x to the 4th minus 1 is equal to 0. And this factors as 2x squared minus 1, 2x squared plus 1. Setting each factor equal to 0, we have 2x squared minus 1 is equal to 0. And we have 2x squared plus 1 is equal to 0. Solving the equation on the left, if 2x squared minus 1 is equal to 0, then x squared is equal to 1/2. So x is equal to plus or minus the square root of 1/2. And that is equal to plus or minus the square root of 1 divided by the square root of 2. And if you rationalize the denominator, this is plus or minus the square root of 2 divided by 2. Solving the equation on the left, if 2x squared plus 1 is equal to 0, this implies that x squared is equal to negative 1/2. So x is equal to plus or minus the square root of negative 1/2. So x is equal to plus or minus the square root of negative 1 divided by the square root of 2. And if you rationalize the denominator, we have plus or minus I times the square root of 2 divided by 2. And the I came from the fact that we have the square root of negative 1 in the numerator. Now we have all 5 zeros of m of x. The zeros are negative 3, square root of 2 divided by 2, negative square root of 2 divided by 2. We have I times the square root of 2 divided by 2, and negative I times the square root of 2 divided by 2. Now I'm going to use these zeros to write m of x in completely factored form. So we have m of x is equal to some coefficient a times x minus negative 3 times x minus the square root of 2 divided by 2 times x minus a negative square root of 2 divided by 2 times x minus I times the square root of 2 divided by 2 times x minus a negative I square root of 2 divided by 2. Now all we need to do is figure out what is this value of a. Well, going back to the original equation, a is going to be the lead coefficient 4. So m of x is equal to 4 times x plus 3 times x minus the square root of 2 divided by 2 times x plus the square root of 2 divided by 2 times x minus I times the square root of 2 divided by 2 times x plus I times the square root of 2 divided by 2. And we are done.